So let's do inverse trigonometry. 2 more questions. First question is sine inverse of root 3 by 2 with a negative sign plus cos inverse of minus 1 by 2 plus tan inverse of minus 1 by root 3. Okay, you have to use negative argument, which is minus sine inverse of root 3 by 2, and this will become pi minus cos inverse of 1 by 2 plus this will become minus tan inverse of 1 by root 3, and the respective values. When will sine be root 3 by 2? Sine at 60, so minus pi by 3 plus pi minus when will cos be 1 by 2? Again, cos is 1 by 2 at 60, so which is pi by 3 again, and minus tan is 1 by root 3. Tan is 1 by root 3 at 30 degree, which is pi by 6. So you just solve this and you should get an answer which is pi by 6. Let's see, this is minus 2 pi by 3 plus pi minus pi by 6, and you know this is 5 pi by 6. Minus 2 pi by 3 plus 5 pi by 6 itself is 5 pi by 5 pi by 6 is LCM is 6 into 3, so it's minus 4 pi plus 5 pi, therefore the answer is pi by 6. So that's the first question's answer in the text. Next is sine inverse of sine 2 pi by 3 plus cos inverse of cos 4 pi by 3. You can write it as sine inverse of sine pi minus pi by 3 plus cos inverse of cos pi plus pi by 3. From here this is in second quadrant. From here this is in the third quadrant. All school tortured children, sine is positive in the second quadrant, so this can be written as sine inverse of sine pi by 3. So pi by 3 is on this side, and let's go to that side. It's like pi plus pi by 3. Solve the inverse trigonometry part. Keep the inverse trigonometry as it is. It become minus cos pi by 3, because in the third quadrant the trigonometry of cos pi plus pi by 3 will be negative, and this is like cos inverse of minus x, which is pi minus cos inverse of x, and in the place of x you can write cos pi by 3. Cos inverse and cos get cancelled, pi by 3 get cancelled, hence the answer is pi. Let's go to third question. Third question is sine of pi by 3 minus sine inverse of minus 1 by 2. This is a negative argument, so it becomes sine of pi by 3 plus sine inverse of 1 by 2, because sine inverse of minus theta is minus sine inverse of x. So then therefore, when will 1 by 2 come in sine? Sine 1 by 2 will occur in 30 degree, which is pi by 6. And a pi by 6 plus pi by 3 is 90 degrees, so the answer is 1. So that's the third sum. Let's go to fourth question. The fourth question is tan inverse of tan 7 pi by 6 plus, I think it's cos inverse of cos 7 pi by 6. This is tan inverse of tan pi plus pi by 6. First solve the trigonometry part. Third quadrant tan is positive, so it becomes tan pi by 6. So this is just pi by 6. Let's solve the trigonometry part. Keep the cos inverse as it is. It's cos pi plus pi by 6. Third quadrant, the cos will become negative. So it's cos inverse of minus cos pi by 6, which is like cos inverse of minus x, a negative argument, which is pi minus cos inverse of x, which is pi minus cos inverse of cos pi by 6. So you have pi by 6 and pi by 6 getting cancelled. The answer is just pi. So that's the fourth question. Let's go to fifth question. So then this is second subdivision, simplify. So then on the simplify in the second subdivision, let's go to first question. A tan inverse of sin x by 1 plus cos x. You're all my students, you know how to write 1 plus cos x is 2 cos square x by 2, and sin x, therefore to sin x by 2 cos x by 2, 2 and 2 get cancelled, cos and cos get cancelled, and so it will become tan inverse of tan x by 2, and so the answer will be x by 2. So let's go to sixth question, or the second subdivision, second question, that which is cot inverse of root of 1 by root of x square minus 1. Whenever I see a sum like this, I know I'll substitute x as secant theta. So theta will be secant inverse of x. So you do that, a cot inverse of 1 by root of secant square theta minus 1, which is cot inverse of 1 by root of tan square theta. The root and square get cancelled. A cot inverse of cot theta is simply theta, which is nothing but secant inverse of x is the answer. So let's go to next sum, which is the third subdivision, which is cos inverse of minus root 3 by 2. And I think there is a plus pi by 6 there. And I know this is whole bracket. This is negative argument. Cos of pi minus cos inverse of root 3 by 2 plus pi by 6. So cos of pi minus, in cos where will root 3 by 2 come? 30 degree, which is pi by 6 plus pi by 6. Cos pi is the answer, which is minus 1. Let's go to fourth question. Next, tan of half of cos inverse of 3 by root 11. I don't like half, so therefore I'll assume cos inverse of 3 by root 11 as 2 theta. Cos 2 theta is 3 by root 11. And then substituting here tan of half of 2 theta, it becomes just a tan theta. You know the association between these two, you know cos 2 theta is 1 minus tan square theta by 1 plus tan square theta. And you know cos 2 theta itself is 3 by root 11 is equal to 1 minus y square by 1 plus y square. So just cross multiplying, you get 3 plus 3y square is equal to root 11 minus root 11 y square. Taking the y square to the other side, it's 3 plus root 11 is equal to root 11 minus 3. Ideally, y square is therefore root 11 minus 3 by root 11 plus 3. And I prefer to rationalize root 11 minus 3 by root 11 minus 3. Denominator is a square minus b square. 11 minus 3 is 8 plus 3, 11, 8. No, 11 minus 9 is 2, sorry. Because a square minus b square is 2. Numerator becomes root of 11 minus 3 the whole square. So y therefore is root of 11 minus 3 by root 2. And that's the answer. And that's nothing but tan theta. So you got tan theta itself. So let's go to the next sum, which is the third subdivision. Simplify a sine inverse of sin x plus cos x by root 2. You can write this as sine inverse of 1 by root 2 sin x plus 1 by root 2 cos x, because I know it is a triplet. So sine inverse of cos 45 sin x plus sine 45 cos x. Why? Because that's when I'll get sin a cos b plus cos a sin b, which is sin a plus b sin 45 plus x. Sin inverse sin get cancelled, pi by 4 plus x is your answer. Let's go to next sum. Prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 is tan inverse of 1 by 2. This is simply tan inverse of x plus y by 1 minus xy. You solve with this, you will get automatically tan inverse of 1 by 2. It's just a question of solving it. Kindly solve it. Let's go to next question. Fifth question. A tan inverse of m by n minus tan inverse of m minus n by m plus n minus pi by 4 is equal to pi by 4. Yeah, I think it's equal to pi by 4. It's a prove that question again. The moment I see this, I will not write it as tan inverse of x plus tan inverse of y. I have another alternative solution where this is like x minus y by 1 plus xy. No, it can't, because there's no 1 here. Absolutely right. So therefore this is like x and this is like y. Okay, so tan inverse of m by n plus m minus n by m plus n by 1 minus m by n into m minus n by m plus n. Just solve this. Tan inverse of LCM will be n into m plus n. So it's m square plus mn plus nm minus n square. Okay. By LCM again here is m into m, what is it? N into m plus n into m plus n. So when you take LCM, it will become mn is n square minus m square. So it's mn plus n square plus m square plus n square. So if you look at this numerator and compare this with the denominator, you have an mn, you have an mn, you have an m squared. Okay, something not okay. Let's see. I will read this once again. Tan inverse of, is it with a plus or a minus? Am I writing the question correctly? Yeah. So tan inverse of m minus n minus m minus n by m plus n by 1 plus m by n into m minus n by m plus n. So tan inverse of n into m plus n be m square plus mn minus mn plus n square by n into m plus n. Again you can write mn plus n square plus m square minus mn. So mn and mn is getting cancelled. Mn and mn is getting cancelled. Denominator is getting cancelled. It's tan inverse of 1, which is pi by 4. So correct. So let's go to the next question. The sixth question is prove that a tan inverse of a cos x plus b sin x by a b cos x plus a sin x is equal to tan inverse of a by b minus x. The moment I see this, I would like to throughout divide by b cos x. Tan inverse of a by b plus tan x by 1 plus a by b tan x, which is tan, this is like x plus y by 1 minus xy, which is tan inverse of x plus tan inverse of y, which is tan x. So tan inverse of a by b plus x is the answer. So let's go to 7th question. The 7th question is tan inverse of 2 into cos of, 1 second, hold on. So tan inverse of, what is the question? 2 cos into, there's a 2 sin inverse of 1 by 2. The moment you look at this, you solve this. The sin inverse of 1 by 2, where will in sin 1 by 2 come? 30 degree, which is pi by 6. A 2 into pi by 6 is pi by 3. So it's cos pi by 3. A cos pi by 3 is 1 by 2. Bring the 2 down. 2 and 2 get cancelled. Tan inverse of 1 is simply pi by 4. So let's go to 8th question. So next question is prove that a tan of half of sin inverse of 3 by 4 is equal to 4 minus root 7 by 3. So the moment you see half sin inverse, so you'll write sin inverse of, so let's write sin inverse of 3 by 4 as 2 theta. So sin 2 theta is 3 by 4. So tan of half of 2 theta is simply tan theta. And you know relation between sin 2 theta and tan theta. Sin 2 theta is 2 tan theta by 1 plus tan square theta, where sin 2 theta itself is just 3 by 4. And you can assume this is 2y by 1 plus y square is equal to 3 by 4. 8y is equal to 3 plus 3y square. A 3y square minus 8y plus 3 is equal to 0. You have to use minus b plus or minus. A minus b is a plus 8 plus or minus root of b square minus 4ac minus 4ac, 9 4s are 36 by 2a. So 8 plus or minus root of this itself is 64 minus 36. It's 14 here, and this becomes a 5, and this becomes an 8. 8 and 2, 28. 7 4s are 28 by 6. You can just cancel the whole thing. The root 4 will become a 2. So it's 4 plus or minus root 7 by 3 by cancelling throughout with, and you got the answer. It's 4 minus root 7 by 3. Let's see. There are two answers, 4 minus root 7 by 3 and a 4 plus root 7 by 3. And a 4 minus root 7, and whatever the root 7's value you can substitute. So just leave it like that. You don't have to do anything. Just leave it like that because you already got the answer. So one of the answers available here, a 4 minus root 7 by 3, and that's the right answer. Let's go to the next question. The next question is a 9th question, where you have 4 into cot inverse of 3 plus cosecant inverse of root 5 is equal to pi. This is a proof that sum. Okay, 4 into, let's convert into tan inverse of x plus tan inverse of y. That's easy. Or we can, that's easy. This is tan inverse of 1 by 3 by using reciprocal function. This you can do a triangle. Cosecant is hypotenuse by adjacent. Hypotenuse by opposite, because cosecant is the reciprocal of sine. Therefore, it's root of 5 minus root 5 square minus 1, which is 5 minus 1, 4, so it's 2. So then therefore it is tan inverse of 1 by 2. So it's 4 into tan inverse of x plus y by 1 minus xy, which is 4 into tan inverse of 6 is the LCM, into 2 into 3 by 5 by 6, 6 and 6 get cancelled, 5 by 5 is 1, 4 into tan inverse of 1 is 4 into pi by 4, so answer is just 1. Let's go to next question, the 10th question. Prove that sine of cot inverse of cos of tan inverse of x is equal to root of x square plus 1 by x square plus 2. The moment you see this, you write tan inverse of x as x and 1 and root of 1 plus x square. So you can convert into cos inverse, cos of tan inverse, right? So cos inverse of 1 by root of 1 plus x square adjacent by hypotenuse. These two get cancelled, bring the cot inverse down. And a cot inverse of 1 by 1 plus x square is simply tan inverse of root of 1 plus x square. And I can do a triangle and write opposite 1 plus x square, adjacent is 1. The hypotenuse therefore is 1 plus x square plus 1, which is root of 2 plus x square. So therefore this is going to become the triangle. It's going to become sine inverse of root of 1 plus x square by root of 2 plus x square. The sine comes down from here and sine inverse get cancelled. You get what you want to get. So let's go to the next question, which is the 11th question. Prove that tan inverse of 2 by 3 is half into tan inverse of 12 by 5. So the easiest way, the moment I look at the sum, I can always multiplying both sides by 2. Okay, you can make it 2 tan inverse of 2 by 3 is simply tan inverse of 12 by 5. And if I prove this, I can always prove that, correct? So 2 tan inverse of x formula, which is tan inverse of 2x by 1 minus x square. So when I solve this, it's tan inverse of 4 by 3 by 5 by 9, which is nothing but this 3 and 3 get cancelled. It's tan inverse of 12 by 5. We immediately get this answer. This proof is so easy. But however, if you want to proceed from here and strictly find the answer without multiplying by both sides with the 2, then what you do is tan inverse of 12 by 5. You assume it as 2 theta. Tan 2 theta is equal to 12 by 5. So on the left side, when you substitute, half into tan inverse of 12 by 5 is 2 theta, it simply becomes theta. But what you have is a tan 2 theta. And tan 2 theta is 2 tan theta by 1 minus tan square theta. At 12 by 5 is equal to 2y by 1 minus y square. Cross multiplying 12 minus 12y square is equal to 10y. So then 12y square plus 10y minus 12 is equal to 0. 6y square plus 5y minus 6 is equal to 0. So 36, 18 to now 9 4s are 6y square plus 9y minus 4y minus 6 is equal to 0. So you get 3y into 2y plus 3 minus 2 into, you have a 2y plus 3. So a 3y minus 2 into 2y, 2y plus 3. So y is equal to 2 by 3 and y is equal to minus 3 by 2. You get two different answers. And what is y? Y is tan theta. But therefore tan theta is equal to 2 by 3 or tan theta is equal to minus 3 by 2. You want theta to be the answer, which is tan inverse of 2 by 3. So, but it's very roundabout way, right? Forget about this answer. You got that answer. But don't you think that it's too much? It's too much to do it this way. The easiest method would have been doing like this. That would strike you. So let's go to next question. Which is a 4-mark question. The first sum is the 4-mark question is tan inverse of root of 1 plus cos x plus root of 1 minus cos x by root of 1 plus cos x minus root of 1 minus cos x. So in this you should immediately write it as 1 plus cos x is 2 cos square x by 2, 1 minus cos x is 2 sin square x by 2 by root of 2 cos square x by 2 minus root of 2 sin square x by 2. Where does the tan inverse outside? The root 2 throughout get cancelled. The root and square get cancelled, become cos x by 2 plus sin x by 2 by a cos x by 2 plus minus sin x by 2. You can throughout divide by cos x by 2, become 1 plus tan x by 2 by 1 minus tan x by 2. A tan inverse of this is simply tan pi by 4 minus x plus x by 2. And how you got it, you know how you should justify in school. Tan inverse of tan pi by 4 plus tan x by 2 by 1 minus tan pi by 4 tan x by 2 will justify it. That completes this, and this get cancelled. Pi by 4 plus x by 2 is your answer. Let's go to next question, which is second question, which is tan inverse of cos x by 1 minus sin x is equal to cot inverse of root of 1 plus cos x. No, there's a minus sign, sorry. Minus root of 1 minus cos x, a cot inverse of root of 1 plus cos x by 1 minus cos x. You have to prove that to be equal to pi by 4. So prove that sum. The moment I see 1 plus sin x, it's cos x by 2 minus sin x by 2 the whole square. Therefore, I'll write cos x as cos square x by 2 minus sin square x by 2, which is like a square minus b square by a minus b the whole square, which is a plus b into a minus b by a minus b the whole square. So therefore, this is going to become cos x by 2 plus sin x by 2, a tan inverse of cos x by 2 plus sin x by 2 by cos x by 2 minus sin x by 2 throughout dividing by cos x by 2, 1 plus tan x by 2 by 1 minus tan x by 2, which is tan inverse of tan pi by 4 plus x by 2, where tan inverse and tan get cancelled. And look at this one, it is cot inverse of, you all know this is tan x by 2. No, it's cot x by 2 because 1 minus cos x is 2 sin square x by 2. 1 plus cos x is 2 cos square x by 2. So it will become cot x by 2. Cot inverse and cot get cancelled. You still have a minus x by 2 everywhere. When you bring it, this and this get cancelled. Answer is pi by 4. Let me go to next sum. The third question is tan inverse of x by root of a square minus x square is equal to sin inverse of x by a is also equal to cos inverse of root of a square minus x square by a. Very simple. You know that this you have to substitute x as a sin theta. So tan inverse of a sin theta. So then what do you know? Sin theta is x by a. Theta therefore sin inverse of x by a. Keep it like that. So tan inverse of a sin theta by root of a square minus a square sin square theta, which is tan inverse of a will get cancelled, sin theta by cos theta, which will become a tan inverse of tan theta. The theta simply is going to become sin inverse of x by a. And you proved it. You want to prove it as cos inverse? Draw a triangle. Write opposite x hypotenuse a root of a square minus x square. So this will be cos inverse of adjacent by hypotenuse, and hence you prove this. So let's go to next question, which is the fourth question. Prove that. This question is cot inverse. It's a prove that question. A cot inverse of 2 into tan of cos inverse of 8 by 17 plus a tan inverse of 2 into tan of sin inverse of 8 by 17 is equal to tan inverse of 300 by 161. Okay, the moment you see this 2 tan inverse, Cos inverse, okay, let's do a triangle, convert this into tan inverse. Adjacent is 8, hypotenuse is 17. So you know that it's 17, 17, 49, 7, 7, 8, 9, 10, 11. And then 1 and 1 is 229. 7 is 7, 289. So you know it's root of 289 minus 864. This will be 5. This will be 2. So this will be 15. You can remember this triplet as it is. So then if you know some 15, 17 has to be 8, you can write it as tan inverse of 15 by 8. Where this outside there's a tan and tan inverse get cancelled. There's a 2, bring it down, this and 4 get cancelled. It becomes cot inverse of 15 by 4. Come back here. Just solve the same thing here. Take the right hand side, we'll prove it later. So it's this again is a sine inverse. You have an opposite 8 and the hypotenuse is 17, and you know adjacent will obviously be 15, and a 2 into tan inverse of 8 by 17. Tan and tan inverse get cancelled. This is tan inverse of 16 by 17, and you have it like this. You can always write this as tan inverse of 4 by 15 plus tan inverse of 16 by 17, which is tan inverse of x plus y by 1 minus xy. Solve this. You obviously will get whatever you have to get on the right hand side. Tan inverse of 300 by 161 is something that you would get to the calculation alone. So let's go next sum. Fifth question. A tan inverse of root of 1 plus x square plus root of 1 minus x square by root of 1 plus x square minus root of 1 minus x square. You have to prove that to be equal to pi by 4 plus half into cos inverse of x square. Again here x square is cos theta. Theta is cos inverse of x square. A tan inverse of root of 1 plus cos theta plus root of 1 minus cos theta by root of 1 plus cos theta minus root of 1 minus cos theta, which is tan inverse of 2 cos square theta by 2, 2 sin square theta by 2, 2 cos square theta by 2, 2 sin square theta by 2. Root and square get cancelled, root 2 get cancelled. A cos theta by 2 minus sin theta by 2 by a cos theta by 2 minus sin theta by 2. Throughout dividing by cos theta by 2, 1 minus tan theta by 2 by 1 plus tan theta by 2, which itself is tan inverse of tan pi by 4 minus theta by 2. Tan inverse tan get cancelled. What is theta? You know. So pi by 4 minus cos inverse of x square by 2, and that's exactly what you need to prove. Let's go to 6th sum. Sum is cot inverse of 2x plus cot inverse of 3x is equal to pi by 4. Change it into tan inverse of 1 by 2x plus tan inverse of 1 by 3x, so that you can use tan inverse of x plus y by 1 minus xy. And then this is a solved sum or prove that sum. Obviously a solved sum where you have a pi by 4 on the right side. Take it the tan inverse to the other side. Tan pi by 4 is 1. So take LCM. It's here it is 6. Keep this x square. It's okay. Okay, I know it's 6x only, but you can always keep it as multiply and keep it as 6x square. So here you're going to multiply with 3x. You're going to multiply this with 2x by a 6x square, and here you have 6x square minus 1. This get cancelled. So you have 5x by 6x square minus 1 is equal to a tan pi by 4, which is 1. A 5x is equal to 6x square minus 1. A 6x square minus 5x minus 1 is equal to 0. And you're going to factorize this. 6 ones are 6. So 6x square minus 6x plus 1x minus 1 is equal to 0. 6x into x minus 1 plus 1 into x minus 1 is equal to 0. 6x plus 1 into x minus 1 is equal to 0. X is equal to minus 1 by 6, so x is equal to 1. And you can plug in whichever answer will be apt for this. This is sum number, solve 6th sum. This is sum number 6, in which only this will be the right answer. When you substitute this in the question, it may not work out. Just substitute and verify. The verification answer is very, very important. So only this is the right answer. Let's go to 8th question. Now let's go to 7th question. 7th question is tan of, prove that sum, tan of pi by 4 plus half of tan inverse of a by b plus tan of pi by 4 minus half of tan inverse of a by b. This you have to prove it to be equal to 2 into root of a square plus b square by b. So prove that sum. Look at this question. The moment I see this, I'll write tan inverse of a by b as 2 theta. And moment I look at this, I'll write, that's what tan is, that's all over. Both of them are tan inverse of a by b. So substitute. So a tan 2 theta is equal to a by b. Just proceed with sum. Proceed with the sum. This is tan pi by 4 plus half of 2 theta get cancelled plus tan pi by 4 minus half of 2 theta get cancelled, which is tan pi by 4 plus theta plus tan pi by 4 minus theta, which is tan pi by 4 plus tan theta by 1 minus tan pi by 4 tan theta, okay, plus tan pi by 4 minus tan theta by 1 plus tan pi by 4 tan theta. It's 1 plus tan theta by 1 minus tan theta by 1 minus tan theta by 1 plus tan theta. So when you take LCM, is a square minus b square, and there again it's a square minus b square. What? You get a 1 plus, this will become a plus b the whole square. So it's 1 plus tan theta the whole square plus 1 minus tan theta the whole square. And expanding, it's 1 minus 1 plus 2 tan theta plus tan square theta plus 1 minus 2 tan theta plus tan square theta by 1 minus tan square theta. And as you can see from here, the 2 tan theta is getting cancelled. It becomes 2 plus 2 tan square theta by 1 minus tan square theta. 2 can be taken out, 1 plus tan square theta by 1 minus tan square theta. The moment you see this reciprocal of cos 2 theta, right? So it's 2 into 2 by cos 2 theta. You can write it like this, correct? And go back to the question. What do you have? You have tan 2 theta is AB. But what I've got is cos 2 theta. If tan 2 theta, sorry, is it A or tan 2 theta is A by B? Sorry, tan 2 theta is A by B. So what is cos 2 theta? A tan 2 theta is A by B. This is root of A square plus B square. A cos 2 theta is adjacent by hypotenuse, and you are supposed to get that answer. That's a proof. Let's go to next sum, which is the 8th sum. Solve for x. Solve for x. The question is cos inverse of x square minus 1 by x square plus 1 plus tan inverse of minus 2x by 1 minus x square is 2 pi by 3. So can you see negative argument? So but look at this negative argument here also, because I know only 1 minus x square by 1 plus x square, so I'll take the negative sign out. This is like a negative argument, so I'll write pi minus cos inverse of 1 minus x square by 1 plus x square, and this itself I can write it as 2 tan inverse of x. Plus in this there's a negative sign out, negative argument, minus tan inverse of 2x by 1 plus x square, which itself is minus 2 tan inverse of x. So it's pi minus 4 tan inverse of x. It's a solved sum, so you have to bring the right hand side, which is 2 pi by 3. So pi minus 2 pi by 3 is 4 tan inverse of x. A pi by 3 is 4 tan inverse of x. So it's 12. A tan inverse of x is pi by 12. A tan pi by 12 is x. What is tan pi by 12? Is it 22 and a half? A 180 by 12. 12 ones are 12. 12 5 60, 15 degree, sorry. So tan 15 degree. And you all know how to find tan 50 degree is tan 45 minus 30. So tan 45 minus tan 30 by, you know how to write that, tan 45 minus tan 30 by 1 plus tan 45 tan 30. 1 minus, what is tan 30? tan 30 is 1 by root 3 by 1 plus 1 by root 3. So it's root 3 minus 1 by root 3 plus 1. Of course, you can also rationalize. When you rationalize this, denominator will become 2. Numerator will become root 3 minus 1 the whole square. On expanding, it's 3 minus 2 root 3 plus 1 by 2. This and this is 4 minus 2 root 3 by 2. So can I write it as 2 minus root 3? And that's the answer for the 8th question. Let's go to 10. Now let's go to 9th question. Prove that sum tan inverse of 1 by 3 plus tan inverse of 1 by 5 plus tan inverse of 1 by 7 plus tan inverse of 1 by 8 is equal to pi by 4. Consolidate. Okay, a tan inverse of x plus y by 1 minus xy plus tan inverse of x plus y by 1 minus xy. Just solve this, okay? You will get, if further solve it, you'll get tan inverse of 1 together, so answer will be pi by 4. I'm not solving this, is because simple calculation. So let me go to 10th question. A tan of a cos inverse of x is equal to sine of tan inverse of 2. So question, tan of cos inverse of x. I would like to convert this into tan inverse, and I can simply do adjacent, and so then this is root of 1 minus x square, and tan inverse of root of 1 minus x square by x is equal to, this is sine, so convert this tan to sine, so opposite 2, adjacent 1, so root of 4 plus 1 is root 5. Okay, so then therefore I can write sine inverse of 2 by root 5. So sine and sine inverse and tan inverse is getting cancelled. So therefore I get root of 1 minus x square by x is equal to 2 by root 5. So then on squaring both sides, 1 minus x square by x square is equal to 4 by 5. So it's 5 minus 5x square is equal to 4x square. 5 is equal to 9x square, and x square is equal to 5 by 9. X is equal to root 5 by 3 with a plus or minus. And substitute that in here and check out which one is correct, and they have given x is equal to plus root 5 by 3, and that verification can be done. Let's go to next question. Is the 11th question. If y is equal to cot inverse of root of cos x minus tan inverse of root of cos x, sin y is equal to tan square x by 2. Prove that. Okay, this is a sum which we have already done in the class on the hot sums. So you can write it as a tan inverse of, you can write this as pi by 2 minus tan inverse. Instead do like this, pi by 2 minus tan inverse of root cos x minus tan inverse of root cos x, which is y basic pi by 2 minus 2 tan inverse of root cos x. And you know this is like 2 tan inverse of x, where we have direct formula tan inverse of, but we have a formula which talks about y. We can write it directly in terms of y. So y is equal to pi by 2 minus sine inverse of 2x, which is 2x is equal to root cos x, by 1 minus cos square x, which is 1 minus cos x. You write it like this. So now it's this itself is pi by 2 minus sine inverse, which will become cos inverse of 2 root cos x by 1 minus cos x. And then you can take the cos y to the other side. With cos inverse to the other side, it becomes like this. And then now what you can do is you want sine y, the proof. So you can write cos y as root of 1 minus sine square y is equal to 2 root cos x by 1 minus cos x. Squaring both sides, 1 minus sine square y is 4 cos x by 1 minus cos x the whole square. Then take the sine square y to that side and bring this side. 1 minus 4 cos x by 1 minus cos x the whole square is equal to sine square y. On expanding this, 1 minus cos x the whole square, you have 1 minus 2 cos x plus cos square x minus 4 cos x is equal to sine square y. So look at the numerator. Okay, I made a mistake somewhere. Pi by 2 minus 2 tan inverse. 2 tan inverse. In terms of sine inverse, it has to be with a plus. I'm sorry guys. Just corrected 1 plus cos x, 1 plus cos x. Because I didn't get the answer, that was an indication as to I made a mistake. So this becomes very easy. It is therefore 1 plus cos square x minus 2 cos x by 1 minus cos x the whole square, which itself is 1 minus cos x the whole square by this mailer, it becomes 1 minus cos x the whole square. To get tan square x by 2. You want a sin y, we should get you tan square x by 2. So I'll tell you what. Okay, this is sin square y, which is this is with a plus again. So 1 minus cos x by 1 plus cos x the whole square is sin square y. Just take a root for this. It's 1 minus cos x by 1 plus cos x. And you all know 1 minus cos x is 2 sin square x by 2. Denominator 2 cos square x by 2. Tan square x by 2 is what is sin y. Such a beautiful question. Let's go to next question. Next question is which sum is the next question? Is prove that a chord of that's the sum number 12. A chord of a tan inverse of x plus tan inverse of 1 by x plus cos inverse of 1 minus 2x square plus cos inverse of 2x square minus 1 is equal to pi. Look at this. The moment I see this, I can write it as cot inverse of x, and a tan inverse of x by using reciprocal function. Cot inverse of x is pi by 2, and a cot 90. A tan 90 is infinity. A cot 90 directly becomes 0, so this can be ignored. Plus a cos inverse of 1 minus, I would assume 1 minus 2x is cos theta. Theta is cos inverse of x. So 1 minus 2 cos square theta plus cos inverse of 2 cos square theta minus 1. Okay, so then 1 minus 2 cos square theta is cos 2 theta. This negative formula of cos 2 theta. 2 cos square theta minus 1 is cos 2 theta. This is perfect. So it's cos inverse of cos 2 theta. This is perfect. Whereas this is minus cos 2 theta. Cos inverse of minus cos 2 theta, because this has been switched. So what you do is you write pi minus cos inverse, negative argument, cos inverse of cos 2 theta. Cos inverse cos get cancelled. With a plus there is one more 2 theta. This and this get cancelled. Answer is merely a pi. So let's go to next question. That is sum number 13. A sum number 13 is prove that a tan inverse of a by b by 1 plus a minus b by 1 plus ab plus tan inverse of b minus c by 1 plus bc plus tan inverse of c minus a by 1 plus ca is equal to 0. So look at this. This is tan inverse of a minus tan inverse of b. This is tan inverse of b minus tan inverse of c. This is tan inverse of c minus tan inverse of a. Tan inverse of a, tan inverse of a, tan inverse of b, tan inverse of b, everything get cancelled. Answer is 0. Considering that it's x minus y by 1 plus xy, it's tan inverse of x minus tan inverse of y. The sum became very, very simple. Let's go to 14th question, where if tan inverse of alpha a plus tan inverse of b plus tan inverse of c is equal to pi, you know 180 by 3 is 60 degree. So every angle can be 60 degree. So it's pi by 3 plus pi by 3 plus pi by 3 would make it pi. So what is a? Tan pi by 3. What is b? Is tan pi by 3. What is c? Is also tan pi by 3. A tan 60, what is the value of tan 60? Is root 3 by 2. Root 3 by 2, root 3 by 2. Now you got what is your A, B and C. Now read the question and find whatever they want you to do. They want you to find A plus B plus C is the same as A, B, C. And root 3 by 2 plus root 3 by 2 plus root 3 by 2 is 3 root 3 by 2. And here it's multiplication. Root 3 by 2 into root 3 by 2 into root 3 by 2 is actually 3 root 3. No, it's 3 root 3 by 2 to 4, 4 to 8, is it? How does this work? It's A plus B plus C is ABC. Sorry, this is tan 60 is just root 3. Is root 3, root 3, root 3. Sorry. So then therefore it's root 3 plus root 3 plus root 3 is 3 root 3. And root 3 into root 3 root 3 is also 3 root 3. I'm sorry guys. Okay, I'm drained out. I'm too tired. I'm doing this very late. As you can see, after the class at 9:30, I'm sitting and doing all this. You can always correct it yourself. Let's go to the next question. The next question is the 15th question, which is if cos inverse of x plus cos inverse of y plus cos inverse of z is equal to pi, prove that x square plus y square plus z square plus 2xyz is equal to 1. So look at this sum. I'm just trying to think how I can do this sum. Okay, this is cos inverse of x plus cos inverse of y plus cos inverse of z is given to be pi. And again, the same way, why can't do the same way? You know, this is pi by 6, this is pi by 6, and this is, 60, 60, 60, yeah? Sorry, pi by 3, pi by 3, pi by 3. So what will happen to x is cos 60. Cos 60 is 1 by 2. So can I assume 1 by pi by 2? And can I substitute here? It's 1 by 4 plus 1 by 4 plus 1 by 4 plus 2 into 1 by 8, which is also 1 by 4 is 4 by 4. So answer is 1. So that completes this sum. Let's go to 16th question. Next is if tan inverse of 1 by 1 plus 1 into 2 plus tan inverse of 1 by 1 plus 2 into 3 plus dot tan inverse of 1 by 1 plus n into n plus 1 is tan inverse of 1 or whatever we can find, or theta. What is this theta? So the moment you see this, you should know, you can write it as 2 minus 1 by 1 can be written as 2 minus 1 by 1 into 2. This is 3 minus 2 by 1 plus 2 into 3. And this is tan inverse of n plus 1 minus n, which is again 1 by 1 plus n into n plus 1. So then therefore this is tan inverse of 2 minus tan inverse of 1 plus tan inverse of 3 minus tan inverse of 2 dot tan inverse of n plus 1 minus tan inverse of n. So tan inverse of 2 is getting cancelled. Tan inverse of 3 will get cancelled. Tan inverse of n will get cancelled. The first term of this, that is 1, and last term of that will not get cancelled. Okay, so then it's tan inverse of, is that all with a plus sign or with a minus sign? This is with a plus sign. Okay, so then you know that tan inverse of n plus 1 minus tan inverse of 1 is prevailing, which is like tan inverse of x minus tan inverse of y, which is tan inverse of x plus y, x minus y by 1 plus xy, where 1 and 1 get cancelled, is tan inverse of n by 2 plus n. I've got some answer like this, and they've given it to be tan inverse of theta. So what is theta according to me is n by 2 plus n, and that's the right answer. So let's go to the next question. The next question is the 17th question in the test paper, which is something that we have discussed in the class. Tan inverse of x the whole square plus cot inverse of x the whole square is 5 pi square by 8. Find x. So it's like a square plus b square, which is a plus b the whole square minus 2ab. The whole purpose is to get tan inverse of x plus cot inverse of x the whole square minus 2 into tan inverse of x into cot inverse of x. We have done this in class, is equal to 5 pi square by 8. Can you see this is pi by 2, which is a identity. So it will become pi square by 4 is minus 2 into tan inverse of x, and write this cot inverse of x as pi by 2 minus tan inverse of x. Okay, is equal to 5 pi square by 8. So that you can take it inside, you can solve this. It's pi square by 4 minus 2 and 2 will get cancelled, pi tan inverse of x plus 2 tan inverse of x the whole square, no, 2 is outside, tan inverse of x the whole square is equal to 5 pi square by 8. Taking this to the other side, a 2 tan inverse of x the whole square minus pi tan inverse of x is equal to 5 pi square by 8 minus pi square by 4. So you can solve this. This is 8 is the LCM. A 5 pi square minus 2 pi square is 3 pi square by 8. So you get 2y square minus pi y minus 3 pi square by 8 is equal to 0. You get a kind of quadratic equation where you assume tan inverse of x as y. Now you just have to solve this. And you want to solve it, you can use minus b plus or minus also. A minus b plus or minus root of b square minus 4ac with a minus 3 pi square by 8 will be 6 4s 4ac. So 4 2 2 and 2 3 pi square by 2a. Pi plus or minus root of 4 pi square by 4. So pi plus or minus 2 pi by 4. A pi plus 2 pi by 4 or a pi minus 2 pi by 4. So this is 3 pi by 4 or a minus pi by 4 are the two answers we are getting. And in the sum you got what you are getting is a y. But what is y? Y is tan inverse of x. So tan inverse of x is y. So tan inverse of x is 3 pi by 4. At tan 3 pi by 4 will become x, which is actually a tan pi minus pi by 4 is your x. Second quadrant, all school taught children, minus tan pi by 4 is your x. So x becomes a minus 1. Then you have to take this, which is minus pi by 4. Tan inverse of x is minus pi by 4. Tan pi by 4 is equal to x. X is still 1, so thus you get the answer as 1. Oh, here it is minus 1, is it? And there you're getting 1. When you get two different answers, always take it and substitute it in the question and verify if that will satisfy. And whatever satisfies only should be the right answer. So when you substitute, you get x is equal to minus 1. That's about the 17th question. Let's go to 18th question. If sine of cot inverse of x plus 1 is equal to cos of tan inverse of x, solve for x. Okay, so you have sine of sine inverse. If this is already given, this has already been given, you have to solve for x. The easiest thing for me to do is to write cot inverse, this x plus 1 and this is a 1, and root of 1 plus x plus 1 the whole square, root of 1 plus x square plus 2x plus 1. Oh, is it getting very complicated? So can I look at some other method? Can I, just a thought only, okay? So just a simple thought, it's given cos of, any other method strikes you also, you can try, it's your wish. So it's cos of tan inverse of x, isn't it? So can I just convert into cos of cos inverse first? So it's opposite x adjacent to 1 root of 1 plus x square. So cos of adjacent by root of 1 plus x square, and cos inverse of and cos will get cancelled. So now I have sine of cot inverse of x plus 1 is equal to 1 by root of 1 plus x square. I prefer to take this to the other side so that I get cot inverse of x plus 1 is equal to sine inverse of 1 by root of 1 plus x square. Just a thought, whatever strikes you. And I'm thinking I'll do this triangle. Yes, I'll still do this triangle and convert this into sine x plus 1 and 1. It's root of 1 plus x plus 1 the whole square, root of 1 plus x square plus 2x plus 1 is root of x square plus 2x plus 2. So if you want to write this in sine inverse, it is 1 by root of x square plus 2x plus 2. is equal to sine inverse of 1 by root of 1 plus x square. The sine inverse and sine inverse get cancelled. The denominator can be squared. X square plus 2x plus 2 is equal to 1 plus x square. X square get cancelled. 2x is equal to 1. X is equal to 1 by 2. I'm not sure if what I'm doing is correct. I'm just trying to see what could be the mistake again. Because when the 2 comes that side, it will become minus 1. So x is equal to minus 1 by 2. And that's the right answer for the 18th question. So let's go to 19th question. The 19th question is sine inverse of 6x plus sine inverse of 6 root 3x is equal to minus pi by 2. Solve for x. The right hand side has been given. So what do we do now? The best thing is for us to, I'm just thinking, convert it into tan, right? Just write it as opposite 6x, hypotenuse 1. So this will be root of 1 minus 36x square. So when you write it as tan inverse, it's 6x by root of 1 minus 36x square. Plus again this one is 6 root 3x. So opposite is 6 root 3x and adjacent is 1. Isn't it getting very complicated? Yeah, looks like. So can I find some shortcut method for this? Can I think of any shortcut method for this? Sine inverse of x plus sine inverse of 6 root 3x is equal to minus pi by 2. It's a soft sum, it's not a proof. Therefore, I can always bring this one of it to the other side. So sine inverse of 6 root 3 root x is equal to, oh, there's a minus pi by 2. Shit. Okay, that's the problem. That's going to be an issue because we don't want a minus pi by 2 there. Then the solving gets very difficult. So what am I going to do with this sum? I have to think. So there's a minus pi by 2. Let me try this method. Okay, let me take one of it to the other side. Say this is to the other side. It's okay. So sine inverse of, is it recording? Yeah. Sine inverse of 6 root 3x is equal to minus pi by 2 minus sine inverse of 6x. You take the minus out, you get pi by 2 plus sine inverse of 6x is what you get, no? What you do, keep it like this and if you take the minus sign out, it will become pi by 2 plus sine inverse of 6x. You don't have any such identity. But you already have a sine inverse on the left side, right? Can I bring that sine inverse to this side? So it will become sine of minus theta. So I'll be left with 6 root 3x is equal to sine of minus theta, which is minus sine theta. So sine 90 plus sine inverse of 6x. And this is trigonometry. Sine 90 plus theta is cos theta. You know, sine 90 plus theta is cos theta, trigonometry. 6 root 3x is equal to minus cos sine inverse of 6x. And then you can always convert this sine inverse of 6x as cos inverse of 6x by drawing a triangle if you want. So then, or you can write this as, just draw a triangle. This is opposite 6x. Hypotenuse 1 root of 1 minus 36x square. So I can write it as minus cos of cos inverse of root of 1 minus 36x square. Adjacent by hypotenuse, cos and cos inverse will get cancelled. What is that I have on the left hand side? Is 6 root 3x. So I have 6 root 3x is equal to 1 minus 36x square with the negative sign which gets squared, so it becomes positive. So then now you can consolidate and make it into a quadratic equation. A 36x square minus 6 root 3x minus 1 is equal to 0. And that's what strikes me. So, or I could have squared both sides. Oh, there is a root here, and so I could have squared both sides in here. So it's 36 into 3, which is 108x square, is equal to 1 minus 36x square. So then you can consolidate this and you get 144 x square is equal to 1, x square is equal to 1 by 144. x is equal to plus or minus 1 by 12. You have to verify the solution by substituting this in the question, and you'll get only x is equal to minus 1 by 12 as the answer. Plus 1 by 12 will not be applicable. You have to substitute and check this out. Okay, let's go to 20th question. Wow, that was a very difficult sum. Okay, 20th question. If cos inverse of x by 2 plus cos inverse of y by 3 is equal to alpha, prove that 9x square minus 12xy cos alpha plus 4y square is equal to 36 into sine square alpha. So that's the question. This is something that I have not taught you in the class. I have to teach you this. Okay, this is like cos inverse of A. Cos inverse of x plus cos inverse of y, we have a formula which is cos inverse of xy minus root of 1 minus x square into root of 1 minus y square. How did they get this formula? I want this formula. I'll assume this is theta and this is phi. And there's no meaning for theta and phi, so I'll simply assume cos. And cos theta cos phi minus sin theta sin phi. And what is cos theta? Cos inverse of x is theta. Cos theta is x. Cos inverse of y is phi. So cos phi is y. And sin theta is root of 1 minus x square. Sin phi is root of 1 minus y square. And I've unnecessarily applied a cos. So take it to the other side. So you get a new formula. Cos inverse of x plus cos inverse of y is cos inverse of xy minus root of 1 minus x. The only way to do the sum is using this. And you obviously don't know this formula. It's all omitted portions, but still they are asking cos inverse of x by 2 x into y by 3 minus root of 1 minus x square into root of 1 minus y square. Yeah, so then now what you do? So now that you know how to apply the formula, you have one cos inverse and the whole thing here. So this is cos inverse of xy by 6 minus, if you take LCM, it will be root of 4 minus x square by 2. This is root of 9 minus y square into 3, and 3 2s are again 6. This is also going to become 6. And so this is cos inverse of xy minus root of 4 minus x square into root of 9 minus y square by 6 is all you have, which is equal to alpha. They have given is equal to alpha. Take the cos inverse to the other side, it becomes cos alpha. Take the 6 to the other side, it becomes 6 cos alpha. So now what do you want? They are asking you to prove that, what's the proof? 9x square minus 12xy plus 12xy cos alpha plus 4y square is equal to 36 into sine square alpha. So what you do, take the root to the other side, take this to the other side. Xy minus 6 cos alpha is equal to root of 4 minus x square into root of 9 minus y square. So squaring both sides, x square y square plus 36 cos square alpha minus 12xy cos alpha is equal to 4 minus x square into 9 minus y square. Now multiply this, 9 4s are 36 minus 9x square minus 4y square plus x square y square. X square y square will get cancelled with this, and then what else are you left with? And what is that you need to prove? When you look at what you need to prove, you need a 9x square. Yeah, bring it that side, 9x square left side. You need a minus 12xy cos alpha, which you already have, minus 12xy cos alpha. Then you need a 4y square. Yeah, we have a plus 4y square is equal to, take it to the other side. Anything else left out? You have a 36 minus 36 cos square alpha, which is 36 into sine square alpha, and you proved, and that's the proof that is there. Okay, so let's do such a beautiful question. Let's go to 21st. Of course you can't do the sum. I'll teach you this formula, how I arrive at a cos inverse of x plus cos inverse of y is cos inverse of xy minus root of 1 minus x squared root of 1 minus y squared. 21st question is, prove that a tan inverse of 3 21st sum sine 2 theta by 5 plus 3 cos 2 theta plus tan inverse of 1 by 4 tan theta is equal to some theta. You need to prove this. Okay, that's the question. Prove that is equal to theta. So I am trying to see what I can do. Tan inverse of so the moment I see this, I can write sine 2 theta as 2 tan theta by 1 plus tan square theta. That's my thought. By 5 plus 3 into 1 minus tan square theta by 1 plus tan square theta. So when I solve this, it will be tan inverse of it will be 6 tan theta by 1 plus tan square theta will be denominator. So it will be 5 plus 5 tan square theta plus 3 minus 3 tan square theta. 5 plus 3 is actually an 8. 6 tan theta by you get 5 plus 5 tan square theta plus 3 minus 3 tan square theta. You get an 8 plus 2 tan square theta. That's what you get. And there is a 3, right? There's a 3 cos 2 theta. So you get it like this, and that is solved. And what is on the right side? You have 6 tan theta by. Can I do one thing? Can I just cancel it with divide by 8? I'm just trying to see if I can divide by 8. What is 6 by 8? Is 3 by 4 tan theta by 1 plus divide by 8 is 1 by 4 tan square theta. So tan inverse of 2 tan theta by 1 plus tan square theta means 2 tan theta 3 by 8 tan theta. No, I'm just trying to figure out what is wrong with the question. And just hold on, something not okay. Something's not okay with the question. The question is 3 sine 2 theta by 5 plus, it seems 4 cos 2 theta. In internet, it's given as 5 plus 4 cos 2 theta. So let me correct it and see if that works out. So in that case, there will be a 4 here. So it will be a 4 minus 4 tan square theta. In that case, it will be could be a printing mistake in the question. 6 tan theta by 9 minus tan square theta. Correct? So 9 plus tan square theta. Yeah, that's what you get. And then you can always write this as tan inverse of tan inverse. Okay, this is tan inverse 2 tan theta by 9 plus tan square theta. Is what I get. Is this a solved sum or prove that sum? Oh, you already have a right hand side also, where you have 1 by tan inverse of 1 by 4 tan theta. What do I do with that? I'm trying. Okay, even I don't know how to do this sum. I'm assuming tan theta is 4 by just hold on a bit. Okay guys, so the question is correct only. It seems to be like it's a JE sum. So let's try to solve. There's only a 3 there. There's no 4. So it's tan inverse of 3 into 2 tan theta by 1 plus tan square theta by 5 plus 3 into 1 minus tan square theta by 1 plus tan square theta plus tan inverse of 1 by 4 into tan theta. So what you do now is, let's simplify the first term. You get tan inverse of 6 tan theta by 1 plus tan square theta by a 5 plus 3 into 1 minus tan square theta by 1 plus tan square theta. And then this becomes, let's solve this. You get, when you take LCM, tan inverse of 6 tan theta by 1 plus tan square theta will get cancelled. 5 plus 5 tan square theta plus 3 minus 3 tan square theta, where it will become tan inverse of 6 tan theta by 5 plus 3 is 8 plus 2 tan square theta is all you get. Okay. This is what you get. Where do you get this? You get it in the denominator, right? Yeah, 1 plus tan square theta anyway got cancelled. So you get an answer like this. In addition to this, you also have a tan inverse of 1 by 4 into tan theta again. Can I cancel this whole thing as with a 2? So will I get it like this? Plus tan inverse of 1 by 4 into tan theta. I'm just trying to solve something a little, and I can see that it's 4 minus 1 will give me 3. So I'm just thinking if I can write it as, can I divide throughout by 4? So 3 by 4 tan theta by 1 plus 1 by 4 tan square theta, which is 1 by 2 the whole square. So can I assume this as 3 by 4 tan theta by 1 plus 1 by 2 tan theta the whole square? So, but I'm just trying to think, 1 minus 1 by 4, isn't it 3 by 4? So can I write this product separately as tan inverse of 1 tan theta minus tan theta by 4 by 1 plus 1 by 4 into tan square theta. Oh my god, it gets so difficult. Plus tan inverse of 1 by 4 into tan theta, which itself is tan inverse of 8 tan A minus tan B by 1 plus tan A tan B, which is tan A minus tan B. Which is like, can I write it as x minus y by 1 plus xy? So then can I write it as tan inverse of x minus tan inverse of tan theta by 4? And what about this is tan inverse of tan theta by 4? Isn't this getting cancelled? This is tan inverse of tan theta, so the answer is theta. Such a beautiful sum. Oh my god, such a beautiful sum. To write it as 2 tan theta, all that is easy. But to think of dividing by 4 so that you get 1 here and write it as a product, as a sum, that was amazing.